Okay, so first up, when you came in to class today, you should have picked up 2 goldenrod sheets. What does that mean?
Homework.
That they're homework and that they're due. On the first, so there's 2 different ones. There's a 4.2 with word problem practice. Keep that one out. That's the one that looks like this. Okay, it's got it's got 6 word problems on the back and 4 word problems on the front, actually front and back, whatever they are. Okay, you can decide which one you want to be the front, which one you want to be the back. On the other one, on the 4.2 Intro to Right Triangles worksheet, for some reason theta in number 1 was not printed on when I copied it off yesterday. So you need to add in theta into the upper left-hand corner of that triangle on number 1, because that's the theta that you're going to then find. Okay? Good?
Good.
Awesome. Then I've got 2 warm-up problems here. I'll give you 4 minutes to get them done. You should only need 2. Another minute yet.
We like to call this riveting internets. Because those that are watching, they're sitting there listening to me talk now. Before they were just listening to 2 minutes of silence.
Can't have decimals in a fraction. Oh, that's just sassy.
Look confused. I'm not.
Good, because it's time. Ready? Good to go? What's the first thing I got to do in number 1? I got to find what x is, right? Okay, how am I going to find what x is? Pythagorean theorem, yep. A squared plus b squared, c squared, love it. So it's going to be x squared plus 7 squared equals 11 squared. So that's x squared plus 49 equals 121. So x squared is equal to 72?
Yeah.
Yep. So then I take the square root, right? Right? Do I need to go plus or minus on this one? Why not? Because it's a length. It's the side of a triangle, right? So it can only be positive. Okay? So I would go here, instead of 8.5, I would go here with x is 6 square roots of 2. Okay? So then that's going to allow us to do our wonderful, let's start with cosine. Cosine of theta, ka, that's adjacent over hypotenuse, right? Okay, so that's going to be 6 square roots of 2 over 11. Right? Now, when I flip that over to get my secant, I would normally have 11 over 6 square roots of 2, right? But we don't like those radicals downstairs. So, quick rationalization here. Let me go up here. 11 over 6 square roots of 2 is going to be 11 square roots of 2 over 6 times 2. So that's going to be 11 square roots of 2 over 12. For that one. Yes? Okay. Sine 7 over 11. Cosecant 11 over 7. TOA is going to be opposite over adjacent, so that's 7 over 6 square roots of 2. So that's going to be 7 square roots of 2 over 12. And cotangent is going to be 6 square roots of 2 over 7. Questions on those 6? No? None? None. Love it. Okay? Second one. Find theta if the sine of theta is equal to negative 1/2. Well, where am I going to be where sine is negative? Quadrant 2 is sine negative in quadrant 2. 3 and 4. So that means I need 2 answers, right? Because I didn't have any extra clarification on this one. So I'm for sure in quadrants 3 or 4. Okay. 1/2. So 1/2 is sine, right? So that's x's. So that's pi over 6, right? If I was in quadrant 1. Okay. So that means, so in quadrant number 1, it's pi over 6, which means then in quadrant number 2, it's 5 pi over 6. In quadrant 3, it's 7 pi over 6. And in quadrant 4, it's 11 pi over 6. Okay. And we got to give them both because we didn't have any extra classifications on that. Like, what I mean by that extra one is we didn't have something like this, We didn't have an extra condition that said limit it to this range. Okay? Or like this, where we limit it to this range or limit it to that range. Things like that. Okay? So today then, the real focus of today is I want to get going on some right triangle trig. And so in order to do that, we need to talk a little bit, refresh our memories a little bit about something called an angle of elevation and an angle of depression. These are things that happen out in the real world. Okay? Elevation, the word, means to be up higher, right? Okay? If you're at elevation, you're at a higher height than somebody standing on the ground or somebody at a different spot. Okay? So an angle of elevation means that your eyes are going to have to go up to see the object. Okay? So if you are standing right there on the ground, okay, the angle of elevation would be how high or how far the angle that your eyes have to go to look up to see an object. So let's put an object out here. Okay. So the angle of elevation would be right here. How high they have to go. What? Yeah. But I didn't want you to, because I want you to see something here momentarily. Okay? Angle of depression. So now you're standing up high somewhere and you're looking down on something. So it's the angle that your eyes have to go from horizontal to go down to the object. Okay? Straight out horizontal to go down to the object. So now you would be up here. And this, we'll call it beta, is the angle of depression. Knowing what you know about geometry, if level ground is horizontal, what can you tell me about the angles of depression from one object and the angle of elevation from a person? They're what? They're the same. Okay? The angle of elevation from you to an object is the same as the angle of depression from the object to you. Okay? Because those horizontals are parallel lines. And they're alternate interior angles. Just when you thought you got rid of all of those, bam, they come back. Okay? All right. So, on the front side of 4.2 word problem practice, we're going to do number 1 now. A tree is casting a shadow 60 feet long when the angle of elevation of the sun is 23 degrees, 0 minutes. We want to find the height of the tree. Okay? So, I start all of these problems by drawing myself a right triangle, because all of these problems are going to be solved using a right triangle. Okay? So we're going to make ourselves a right triangle. Doesn't matter which way your orientation is. What part is what from the problem? Or fill in some information for me.
The base is 60 feet long.
Why is the base 60 feet long?
Because, that's basically like, that's the ground. So
This is the ground, yep, so then that's where the shadow lives, right? So the shadow is 60 feet long, so the bottom of my triangle is 60 feet long. Love it. What else do we know? So which? The top one. You didn't sound very confident with your saying the top one.
Like,
What do I have? Do I have an angle of elevation or do I have an angle of depression?
oh, bottom one.
What do I have? I have elevation, so that means I have to go up, right? Okay, so that means that this one down here then would be 23 degrees, 0 minutes. Because my sun, if I were to follow along on this line, however many millions of miles away it is, I don't remember anymore, the sun that one was supposed to connect like that. That's such a pretty sun. No? Yeah, you were laughing at me. Would you like this one instead?
that looks beautiful.
Like that instead? Is that better? Okay. All right. What else do we know?
You can figure out the other end.
We could figure out the other angle if we needed to, but do I need to? No. What do I need to figure out? Where's the tree?
Opposite.
It's the what?
Opposite leg.
Yeah, so it's the vertical side of the triangle, right? And we'll call that x. Okay. So how am I going to figure out what x is based off of that? Tangent? TOA? Okay, so KATOA. So tangent tells me opposite over adjacent?
Yes.
Okay, I thought you said hypotenuse there for
I
a
did,
second.
but I changed my answer.
That was a quick change. So the tangent of 23 degrees, 0 minutes is equal to the opposite side, which was x, over the adjacent side, which was 60. Multiply both sides by 60. We get that. Yes. Come on now. So 60. Oh well, they might have just missed all that explanation. Well, such is life.
usually want angles of elevation or depression in degrees then, or do you only have to solve for them?
Yeah, normally in degrees. So final answer?
How do you do like the seconds on here?
On there, you use your degree, minutes, and seconds key. Yep.
She's got a degree, minutes, and seconds.
On yours, I don't know how you do it.
Oh.
No, you'd have to convert it into a decimal degree. On the Inspires, you do, yes.
I didn't know.
On the Inspires, you have degrees, minutes, and seconds.
I just did like the number over 60.
Yep. Yep. So on the Inspires, it's to get. So if I wanted to do 27, come on, oops. Yeah. Rid of that. Where's my? I would do 27 divided by the tangent of 53, and then I got to go degrees, and then I've got to go, what was it, 29 minutes? Or was it 27? 29. 29, and then minutes is this one right here.
If you wanted to do seconds, would you just do two of those?
Two of those then, yep, on the Inspire. Yep. And then when I hit, oops, gotta keep my calculator there. And then when I hit enter, there's my, okay. So what do we got for a final answer? No.
9.525.
Meters.
No.
9.5 meters.
No.
9.5 meters.
No.
10.
10.
Why does it say 9.5?
Because on there we wanted to show you that where it was. Because on there it's got to be 10 meters. Could be from 9.5 all the way up to 10.49. You know what I mean?
Yeah.
So I wanted to.
So even if you like, because I didn't know how to do the seconds thing, I just used degrees. I would have still like had it rounded to like the right number.
Sure. I don't know. I didn't.
You just don't know how to work your calculators.
You could go on blind faith, yeah, or yeah,
Hopefully.
Okay. Kevin, did you have a question?
Yeah, I just don't know how to hit the seconds.
Seconds on yours?